Good day everyone, I'm Alina Medios and I'll be teaching you the constant rule of integration. So our formula is the integral of k dx is equal to kx plus c. So if our k is our constant, then the integral of our constant will be a linear expression, or where each term is either a constant or a variable raised to the first power. So for our first example, the integral of 9 dx is equal to 9x plus c. So what we did here is simply to copy the constant and add x next to it. And since this is an indefinite integral, we will always have to add plus c. This is because of the fact that once you take the derivative of a constant, you will always get 0. So for our second example, integral of 70 dx is equal to 70x plus c. And lastly, number 3, the integral of 1 dx is equal to, we repeat the same thing again, so x plus c.
Good day, my name is Ariel Diodolfo Ardeleon and I'm here to teach you some basic integrations. So in here we have the formula, the integral of x to the power of n dx is equal to x to the power of n plus 1 over n plus 1 plus c. To better understand this formula, I will give you two examples, and my two examples are the integral of x to the power of 5 dx, and my second example is the integral of 10x to the power of 4 dx. So you can pause this video and answer this given samples. So what I did on number 1 is that I followed this given formula, and it states on the formula that you have to copy x to the power of n, which is this one, and then add 1, and then copy n plus 1, and then add plus c. So you can see that I did that certain process here on my first example. You can see that I just copied x to the power of 5, which is this one, then I add 1, and then I bring down 5 plus 1. So if you solve this one, it will give you the answer x to the power of 6 over 6 plus c. On my second example, we have the integral of 10x to the power of 4 dx. So as you can see here, I just copied 10x to the power of 4, which is this one, and then I add 1. Then I will bring down 4 plus 1, which is this one. So if you answer this one, it will give you the answer 10x to the power of 5 over 5. So you can simplify this answer by simply cancelling 10 and 5. So your answer will be 2x to the power of 5 over 5 over, no. So that's it. This will be your final answer. 2x to the power of 5. So moving on, we have the formula. The integral of 1 over x dx is equal to ln x plus c. So in here, to understand this formula, I have given you two examples. And my first example is the integral of 1 over 3x dx. And my second example is the integral of 1 over 7x dx. So what I did on number 1 is that I look at this example as two parts. So the first one is 1 over 3 and then 1 over x. So I just separated them. So 1 over 3 multiplied by the integral of 1 over x dx. So if you solve this part, it will give you the answer 1 over 3 ln x plus c. So on to my second example, I have given the example the integral of 1 over 7x dx. So what I did on number 2 is what I did on number 1. I just looked at this example as two parts, 1 over 7 and 1 over x, and then multiply them. So it will be 1 over 7 multiplied by the integral of 1 over x dx. So if you solve this example, it will give you 1 over 7 and then x plus c. Moving on to our third part of basic integration. We have the formula, the integral of e to the power of x dx is equal to e to the power of x plus c. So to better understand this formula, I will give you 2 examples. So my first example will be the integral of 3e to the power of x dx, and my second example is the integral of 15e to the power of x dx. So what I did on number 1 is that I looked at this example as 2 parts. So I separated 3 and e to the power of x. So what I did here is that I multiplied 3 to e to the power of x dx. So you can see here that I just wrote that one, 3 multiplied by the integral of e to the power of x dx. So if you solve this one, it will give you the answer 3e to the power of x plus c. On my second example, what I did here is that I just followed the formula and what I did on number 1. So I looked at this example as 15 and 3 and e to the power of x dx. Again, I multiplied the both of them. So 15 multiplied by the integral of e to the power of x dx. So if you solve this one, it will give you the answer 15 e to the power of x plus c. And that's all.
So one of the basic rule of integration is integral of e raised to kx dx is equal to 1 over k e raised to kx plus c. So here we're going to have an example. So number 1 is integral of e raised to 5 over x. So as we can see here in the formula, we need to follow this one. So it will become 1 over 5 e raised to 5x plus c. So we can combine this one into fraction. So the final answer will be a raised to 5x over 5 plus c. So this is the final answer. So number 2, integral of e raised to 3x. So again, we need to follow this one, the formula. So it will become 1 over 3 a raised to 3x plus c. So again, we can combine this by fraction. So we can multiply. So the final answer will be e raised to 3x over 3 plus c. So, okay, now we're going to discuss the integration by parts. So integration by parts is a simple method of integration that is often useful when two functions are multiplied together, but it's also helpful in other ways. So in integration by parts, we're going to use the Deliate. So L will be the logarithmic, I is inverse, A is algebra, T is trigo, E is exponential. So in integration by parts, we need to follow this formula. Integral of u dv is equal to uv minus integral of v du. So integration by parts, example number 1. So integral of x e raised to x dx. So again, we need to follow Deliate. So here, as we can see, this is algebra while this one is exponential. So u will be x, du is dx, v will be e raised to x, the derivative of b is e raised to x dx. So we need to follow the formula, the given formula for integration by parts. So substitute this given to this equation. So it will become integral of x e raised to x dx is equal to x e raised to x minus integral of ex dx. So again, the integral of ex is e raised to x. So the final answer will be x e raised to x minus e raised to x plus c. So here are the example number 2 for integration by parts. So integral of x cosine x dx. So again, we need to follow Deliate. So here in this equation, we can see that x is the first one because it is algebra, while this one is trigonometry. So again, u is x, du is dx, dv is sine x, v is cosine x. So again, after finding the v and u, we need to substitute using this formula. So it will become integral of x cosine x dx is equal to x sine x minus integral of sine x dx. So again, the integral of sine x is negative cosine x. So it will become x sine x minus negative cosine x. So this one, we can multiply this operation, so it will become positive. So the final answer for this equation is x sine x plus cosine x plus c. So that's it.
So now let's move on to the integration of substitution. So sometimes you can't integrate right away, so you have to change the integral to make it easier and less complex to integrate by substituting it with u. So our substitution rule is written as the integral of x times g of x times g prime of x dx is equal to integral of f times u du, where our u is our g of x and our du is our g prime of x dx. Now let's get to the first example, the integral of cosine times the quantity of 4x plus 3 dx. So the first thing we have to do here is to represent our inner function as u. So u is equal to 4x plus 3. Then we get the derivative of our u. So du is equal to 4 dx. And since our integrand doesn't have the 4 dx term written here, we have to multiply both du is equal to 4 dx by the reciprocal of 4, which is 1 over 4. So it will be dx is equal to 1 over 4 du. Now we solve. So integral of cosine times the quantity of 4x plus 3 dx is equal to integral of cosine u, now we substitute, times 1 over 4 du. And since 1 over 4 is a constant, we can just put it in front. Now it's equal to 1 over 4 times the integral of cosine u du. Now we integrate 1 over 4 times the integral of cosine, which is sine, so times sine u, plus c. Always remember to put the plus c. Our final answer will be 1 over 4 sine times 4x plus 3 plus c. Now let's get into the second example. So the integral of the quantity of 2x minus 5 raised to 4 dx. So again, we have to represent our inner function as u. So u is equal to 2x minus 5. Then we got the derivative of our u. So du is equal to 2 dx. And since we don't see the term 2 dx here in our equation, we have to multiply du and 2 dx by the reciprocal of 2, which is 1/2. Now we solve. So we now substitute. So in the integral of u raised to 4 times 1 over 2 du. So again, we have a constant here, so we can just put it in front. So 1/2 times the integral of u raised to 4 du. Now we integrate. So we integrate it by using the power rule of integration. So 1/2 times u raised to 4 plus 1 over 4 plus 1 plus c. So it will be 1 over 2 times u raised to 5 divided by over 5 plus c. So we now multiply 1 times u raised to 5 and 2 times 5. So we will get u raised to 5 plus 10. always remember our plus c. So now we put it back to its original term. So 2x minus 5 raised to 5 over 10 plus c is our final answer.
So we are going to discuss about the definite integration. So indefinite integration has a start and end values. In order the words there are interval of a and b. So here this is an integral sign. This is a is the lower limit while b is the upper limit. So integral of a to b f prime of x dx is equal to f times b minus f times a. We can use this in evaluating the given equation. Example number 1 is integral of 2 to 3 8x cubed plus 3x squared plus 6x dx. So first, we need to integrate this one. So we're going to use the rule in exponential. So in exponential, we're going to add the exponent and we need to follow it in the denominator. So 8x plus raised to the power of 3 plus 1 over 3 plus 1 plus 3x raised to the power of 2 plus 1 over 2 plus 1 plus 6x raised to the power of 1 plus 1 over 1 over 1. So we are going to add the exponent. So it will become 8x raised to the power of 4 over 4 plus 3x raised to the power of 3 over 3 plus 6x raised to the power of 2 over 2. So as we can see here, we can simplify. So it will become 2x raised to the power of 4 plus x cubed plus 3x squared integrate into 2 to 3. So after that, we're going to follow the given formula earlier. It is f times b minus f times a. So here we need to substitute the upper limit and then the lower limit. So we need just 3, you need to substitute it in every x in the exponent. So we just need to substitute. So after that, we need to simplify them. So it will become 2 times 3 raised to the power of 4 is 162. 3 raised to the power of 3 is 27. So 3 times 3 raised to the power of 2, and then minus 2 times 2 raised to the power of 4 plus 2 raised to 3 plus 3 times 2 raised to 2. So it will become 162 plus 1 plus 27 plus 27 minus 32 plus 8 plus 12. So if we add this one, it will become 216, while this one, it will become 52. So 216 minus 52 is 164. That is the final answer. So example number 2 is the integral of 0 to x squared minus 10x minus 4 dx. So again, we need to integrate them, and by integrating this, we need to follow the exponential rule in integration because it has an exponent. So again, we just need to add the exponent to plus 1. So here, so it will become x raised to 3 over 3 minus 10 x raised to 2 over 2 minus 4x. So again, we can simplify this one. So it will become 3 raised to x over x minus 5x squared minus 4x. We need to integrate them from 0 to 5. So again, we need to follow the given formula, which is f raised to b, which is the upper limit, minus f times a, which is the lower limit. So we just need to substitute 5 in the equation, and then minus we substitute 0 in the equation. Since substituting, it will become 5 raised to 3 over 3 minus 5 times 5 raised to 2 minus 4 times 5 minus 0 raised to 3 over 3 minus 5 times 0 raised to 2 minus 4 times 0. So again, in rule, in mathematics, everything that is multiplied or divided by 0 is equal to 0. So we just need to cancel this equation. So we just need to integrate, to substitute this, to evaluate this equation. So it will become 125 over 3 minus 125 minus 20. So we cannot subtract this one if they are not in the same denominator. So we're going to use the common denominator, which is 3. So from this one, it will become 125 over 3 minus 375 over 3 minus 60 over 3. So as we can see here, they have the same denominator, so we can subtract this equation. So if we subtract 125 over 3 minus 375 over 3 minus 60 over 3, it will become negative 310 over 3. So this is the final answer.